Chapter 5, Force and Motion. By the end of this video, you should know the definition of force, Newton's first law and Newton's second law, as well as knowing how to identify forces and drawing free body diagrams.
Force is a fundamental concept of dynamics. It can be a push or a pull, it acts on an object, it's a vector, it can be contact or long range, and it requires an agent, which is something to push or pull it. One example of an agent would be your hand when you throw a ball. Your hand is the agent that makes the ball move. Contact forces are forces that act on an object by touching. A soccer ball must be hit by your foot in order to move. A long-range force is a force that acts on an object without physical touch, like a raindrop being pulled to the earth by gravity. Net force is the sum of all forces that are acting on an object.
Some examples of forces we'll be looking at throughout this chapter are gravity, spring, tension, normal, friction, drag, and thrust.
When it comes to forces, it's important to understand the following two laws. The first law is Newton's first law. Newton's first law states, an object that is at rest will remain at rest, or an object that is moving will continue to move in a straight line with constant velocity if and only if the net force acting on the object is zero. The second law we need to know is Newton's second law. It states that the sum of all forces, known as the net force, is equal to the mass times the acceleration.
With this new information, let's look at this example. A bungee jumper has left off a bridge and is nearing the bottom of her fall. First, we need to identify the object of interest, like the human in the picture. Second, we should draw a picture of the situation. Third, we should draw a closed curve around the object. Fourth, locate every point on the boundary of this curve where other objects touch the object of interest, which the other objects are the rope, and the object of interest is the human. Fifth, we should name and label each contact force acting on the object, for example, the tension on the rope. Sixth, we should name and label each long-range forcing acting on the object, for example, the gravity. With these steps, we can identify the forcing acting on a bungee jumper.
Alright, now that we know how to identify forces, let's take a look at this problem. So, an elevator suspended by a cable speeds up as it moves upward from the ground floor. So the first step we want to take is to identify all the forces acting on the object. So in our picture right here, we identified the tension of the cable and gravity, which is pulling down. Next, we want to draw a coordinate system, just like this, the x and the y. Third step is to represent the object as a dot on the axis, on the origin of the coordinate axis, which is that orange dot right there. Next step is to draw the vectors representing each of the identified forces. So in this case we have tension, which is pulling up, and we have gravity, or the force of gravity, which is pulling down. Okay. Now if you look closely, the magnitude of the tension vector is larger than that of the force of gravity. Right. Last but not least, we have to draw and label the net force vector. Now if you recall, net force is the sum of all the forces acting on an object. So if we come back to our free body diagram, we see that the magnitude of the tension is larger than that of the magnitude of gravity. So because our elevator is moving up, we have a net force which is moving up.